Questions 9 and 10 deal with the graphs of the polar equation and trying to analyze where's the maximum and minimum values and what values of theta are where the radius is 0 or where the graph goes back to the origin. So when we were graphing the equations on the calculator, we saw that when it was drawing the picture it would always kind of loop back to the origin. So we're trying to figure out when is that happening. Okay, but the first thing we're going to look at is the maximum and minimum values. So I'm going to try and build this up from just a normal sine function into what we have here. So I know just from our basic graphs of sine that sine of theta goes between -1 and 1. That's just looking at the basic graph of sine. So 5 sine of theta, because we changed the amplitude, this goes between -5 and 5. So this r value here, the minimum that it's going to be, because it's equal to 5 sine of theta, the min is -5. The max is 5. For part B, finding the values of theta where the radius is 0, I'm going to set r equal to 0. So if r is 0, then I can set 5 sine of theta equal to 0. So 5 sine of theta equal to 0. And then if you solve and divide both sides by 5, sine of theta is 0. And if you look at the unit circle, where does that happen? That's at 0 and at pi. With question number 10, it's the same type of question. We have a new equation, 1 plus 2 cosine of theta. So for part A, cosine of theta goes between -1 and 1. 2 cosine of theta goes between -2 and 2. So I'm trying to build up into this equation here. So if you change the amplitude to 2, it's going now between -2 and 2. And then if you do 1 plus 2 cosine of theta, that's shifting everything up 1. So that goes between -1 and 3. So since r is equal to that, then the minimum value of r is -1, and the maximum value of r is 3. For part B, it's where is r equal to 0. So if you set r equal to 0, it also sets that equation equal to 0. And, oops, I forgot my 2. There we go. If I subtract 1 from both sides, and then divide by 2, cosine of theta is equal to -1 over 2. And if you look at the unit circle, this happens at 2 pi over 3 and 4 pi over 3.